Okay, so here we are in the opening screen of Quick Model with energy gauge loads. And as you can see, it's sort of a virtual reality type thing. There's a sky and a ground and sort of a building pad here, which is where our plans are going to go. And our first job is to name our project. So we'll just call this test project. And I'll just give it some fake address information for now. Okay, so I'm going to go ahead and go through this process. I'm going to speed it up through the repetitive and boring parts, and but pretty much hit all the essential parts that we talked about during the slide presentation portion. And you remember there was 4 steps to the process. There was collecting information about the house, there was doing load calculations, there was selecting equipment, and then there was designing your duct system. We'll go through each one of those 4 steps, but using the software, which is much more common. There are other software programs out there. This is just the one that I'm most familiar with because I designed it. It's a great training tool, let me put it that way. Okay, so step 1, collect information about the house. So we need to know all the wall areas, the floor areas, and things like that. So the best way to do that, let's say we're designing a new house, so we have some architectural plans for this house, and so we need to import those into our design. So up here, we'll click on floor plan. You'll notice there's some elevations here. We're going to keep it nice and simple, but there's a lot of things you can change that I'm just going to kind of skip through. Okay, so we need to import a floor plan, and I will import the first floor first. So I double clicked on that drawing file and it brings a floor plan in, and you can kind of tell that it's not to scale. So our first step is to make the drawing to scale. Click on top, click on 2D view, and look right straight down. Okay, and there's a command here, it says scale floor plan. So I click on that and you'll see these arrows come up here. So there's one arrow's running left to right and one arrow's running front to back. Doesn't matter which one you do first, but you want to take those arrows and you want to drag them out to the longest dimension you can find. So I see 44 feet here, and the reason you want to do the longer one is because the longer it is, the more accurate this scaling will be. Okay, so I get it to line up there. That's 44 feet. I come down here to the bottom left, 44, hit enter. Now from there to there, if I were to count the little number of squares, would be 44 of those. Okay, so we're to scale going left to right. Now we need to do the same thing for front to back. So I see 27 feet here and I see 6 feet here down here. So let's go ahead and add those together. So from there to there is going to be 27 plus 6 is 33. Hit enter, and there we go. Okay, so now from there to there is 33 feet on the architectural plans, and it's 33 feet on our drawing background. Now the next thing we need to do is just get things lined up a little better. So if you look over here, I can click move floor plan, and I can get that corner to line up with the grid in the background. Okay. Alright, so now we've got our first floor placed and it's all to scale. You can see there's a garage over here that's not conditioned. We've got a living room, a dining room, a kitchen, laundry, bath, entry, and a den, and some stairs going up. Okay, so that's our first floor. So now we need to basically build this house out of a 3D model, and it's really simple. Go to rooms, and you have some choices here. We're going to start off with a basic square box. The default size is going to be 10 foot by 10 foot, and remember we set the ceiling height to 8 feet. So you just hit Alt key, click, and it places a room that's 10 by 10. Now you just need to drag that room around and get it to line up with the floor plan. Okay, so we're going to get it down to here, and this living room, dining room, kitchen, it's kind of arbitrary where you stop them. What's important is you look at the windows. So you got a big window here and you got a sliding glass door here, and so you kind of want to even them out. This area will probably get a supply register, and this area will probably get a supply register, if not two. And so you kind of want to even them out as much as you can. So you got a big sliding glass door here, plus you got another window here, plus you have a lot of kitchen load. So I'm gonna make the living room a little bit bigger. Okay, it's mostly going to be the windows and the appliances in the kitchen that's going to drive the load over here. So it doesn't really matter if you add it here. It might put a little bit more air over here. It doesn't matter in the grand scheme of things. This is going to get some air. This is going to get some air. The load for both of those spaces will be accounted for because of the way we do the calculations. So it might just shift a little air one way or the other. What you don't want is to have like a 6-inch duct coming down over here and a 10-inch duct coming down over here. You want to kind of even those out as much as possible. Okay. So Alt click places another room. Just drag it out to match the size of the room below. Then we have a den down here. I like to go ahead and show the garage on the plans because it looks the 3D model looks funny if you don't. But what I'm going to do is I'm going to come over here. I've got the garage selected, and I'm going to designate the garage as unconditioned. So you see it changes color, so it won't be calculated in the loads, but it'll show up in the drawing so that it looks more realistic basically. Come down here, let's place another room. It's a little bigger than we need it to be, so we'll slide this over, get it to tuck back in there, and get those all to line up. Now we got a bath and a laundry room, so you can grab the corners and do it like that. Okay, so that's our first floor. We've got all the rooms put in there. Each one of these spaces is going to get its own load calculation. If it turns out that it needs a lot more air than one duct will handle, we can put 2 registers in there if we need to, but we'll start off with 1 because I think that'll work. Next thing we need to do is put the windows on here. So you notice I'm in 2D mode over here. I've got 2D checked, and I'm looking straight down from the top. Okay, so let's take it out of 2D mode and let's look at it from the front. And there we go. That's our first floor with all our rooms put together. Now what the software is doing is it's looking at each one of these boxes and it's calculating the wall areas, the floor areas, the ceiling areas, and things like that. Now we're gonna put a second floor on top of that, so the ceiling areas don't really matter at this point, but these wall areas definitely do. So we've got a front wall here, we've got a left wall here. This garage is not being counted because it's conditioned, but this wall here is between the den and the garage, so we do need to calculate that, and it is accounted for. Okay, and so the software is doing all those calculations. Now the other thing, if you'll recall, that's important is not just knowing the areas of those walls, but what kind of wall are they. And so back here in libraries is where you can set all your different types. So you got windows, walls, doors, floors, ceilings, rooms, roof, and ducts. Okay, so the walls types, you have some choices built in here, and you can barely see it, but this first row is highlighted green. You can see some green highlight in the background there. So the one that's green is the default. So when I place these rooms, the software is automatically assigning these rooms to be the default, which in this case is a 2x4 R13 wall, which is very common. Okay, not in brand new construction, but in older homes it is. Okay, and there's other the R value and the framing factor and things like that come into play here. Okay, if you wanted to start off using a different wall, you could just select a different wall here. Also, if this wall in here was different than all the rest, you can go into another table and assign each wall a different type. Okay, but the libraries is where all your choices are, and it's where the default wall is established. Okay, so let's go into this tab here, which is data. This is where all the tables are for everything that's placed, that all the calculations, all the areas are done. So if I go into the wall table, you'll see there's a whole bunch of walls here. Okay, and actually what I should probably do first, let me go into the room table, and you see we placed all these rooms. So if I click on it, it lights up, it's highlighted, and that's room 1. or if I click in the table, it highlights it in the table and also highlights it down here. So room 1 is this, and I can just scroll down. Room 2, room 3, room 5. Apparently I deleted a room or something. Oh, it's probably the garage. It's just going to number the rooms in order that you created them, and it's just assigning temporary names, and you can change those. So room 6 and room 7. So let me go on in and name these room. Room 1 is the living room. It says lining room. It's actually the living room. Okay, so I'm just going to shorten. I'm just going to say living, L-I-V. Okay, this. Okay, so now we've got our rooms named up here, and then when we go to the wall table, it'll have our walls. It numbers them just with a number. Okay, and you can change that too, but it also says which room that wall is assigned to. So if I click on this wall here, it's in the living room. It's the default 2x4 R13, and you can go in and change that if you want to. It's 152 square feet. It's facing the back. It's facing north. If we look at our north arrow, yep, that's the north direction. Now if I were to change this north arrow, I have to go out of the table and back into it. Now it shows that that wall is facing west, which it is. Okay, I'm going to go back to north because that's just easier to comprehend for now. Okay, now it's facing north. Okay, so that's that wall in the living room. Wall number 2 is that wall, and notice that it says over here there's a column that says touching. What is it touching, or what is it adjacent to? So this first wall is touching outside. This wall is touching an unconditioned space, which happens to be the garage. Okay, this wall is that wall there, wall 4, wall 5, 6, 7. Notice that it treats these two walls differently, because this is between the den and unconditioned space, and this is between the den and outside. Then we have a front wall on the den. Then we have the entry, powder room, and then the laundry room has 2 walls on both sides. Okay, so this, once you create this 3D model, the software puts it all together and does all the area calculations for you. Okay, now the next step is we got to put some windows on here, and you can see the windows labeled on the floor plans here. So this is fairly common architectural nomenclature, 2636. What it is, it's width and height, and it's feet and inches. So it's 2 foot 6 inches by 3 foot 6 inches tall. That's the same. So there's 4 identical windows, and then here's a door. It's a 3068 door. Okay, so the way you place those in here is very simple. You just again hold the Alt key down, and you click and you drag to be the approximate width as the window on the plans. And that's just to help you quickly determine if maybe the plans are off. If they've drawn a 5-foot wall window but labeled it as 4 feet, you can figure that out pretty quick. So 2 foot 6 is 2.5 feet, and so here is 2 foot 5 something inches, so that's pretty darn close. And the way to enter this window size is using these numbers. 2636 is you just type those in, 2636. And then the other thing it wants to know is the distance from the top. And usually windows, the top of windows are the same height as the top of doors at 6'8". So that means they're about 1 1/3 feet down from the top. So distance from top, I'm just going to type 1.3, hit enter, and there you go. So that's a 2636, 1.3 feet down from the top. And there's 3 other identical windows, so that's real easy. You click on the window, hit Control C, and then Control Alt click will place an identical window at the same height in those locations. Okay, now we got a door. The default size for a door is a 6068, which is very common for an entry door. Just click it and it puts a door right there. So there's our door and our windows. So those are done. Okay, very simple. All right, let's go around to the side of the house here. We've Okay, so there's our first floor, all done. Very easy. All right, now we'll go back to floor plan, elevations, and now we need to add a second floor, so add floor. Now you can see there's another place to put a floor plan. So we will import a floor plan. There's the second floor, so it's the same process as the first one. And it looks like there's this little cantilever hanging out over the back here. Okay, but we got our first floor to line up nicely with the second floor above. Okay, now we can build our second floor. Now you have to make a little bit of a design decision at this point. You're definitely going to have a supply register in the master bedroom, maybe even two. You're going to have one in the master bath. Now the question is, are you going to put one in this toilet room or not? And it just depends. There is a window in there. It depends on the climate. If this was in Las Vegas, this toilet room would get really hot if it didn't have a register in it. So I'll go ahead and put a register in there, and then I'll also put one in the master bath. If I were not going to put the register in this toilet room, I would want to combine the load of this room with the master bath. In other words, the register that I put in the master bath has to handle the load of the master bath as well as this little toilet room. And to do that, I would group those two rooms together. And so I would select one and then hit down shift, select the other one. You can see they're both highlighted, and then I come over here and I group those two rooms together. And the way to tell that they're grouped together is if you move one, they both move together. They've been grouped. Okay. Now, I just said that I'm gonna put a separate register in this room, so I need to ungroup those. So they do need to have their own loads for each one. Each one's going to get its own register. But also notice here, let me turn off the first floor again, and I can also make the floor plan a little darker by sliding this bar down here. There's a walk-in closet here, okay, and this walk-in closet passes through here to the master bath. Now the next question is, do we want to put a register in this walk-in closet? And normally I would say no. If it only has one exterior wall, I would say no. If it had two exterior walls and it was on a corner and maybe had a window in it or something like that, then I would say yeah, but that's not an occupied space. People don't spend a whole lot of time in the walk-in closet, relatively speaking. So I'm not going to put a register in here, so I will group the walk-in closet with one of the other rooms. And since the toilet room is so small, I'll go ahead and group those together like so. And you don't have to do this. There's different ways to skin a cat. You can try it different ways. Oops, sorry, ungroup. There's different ways to do this, but I chose to group these two loads, and whatever register I put in this room will be enough for the air to handle the load for both of these spaces. And again, it's just arbitrary. You could put a register in every single room, but you'll find that sometimes it's just not worth the extra cost. That this room will basically be conditioned by the spaces around it. Okay. All right, we've got a bath here. People generally like registers in baths even if they don't have a load. Got a little closet here. That closet is part of bedroom 3. So I'll go ahead and group it with bedroom 3. Got a bedroom over here. Bedroom 2. Okay, now we've got another design decision to make here. We've got this little landing area at the top of the stairs. It might be a little place to put a desk or something like that. So this room will get a register, this room will get a register, and it looks like this room probably will get a register. It's got a window, there'll probably be a desk or something here. So let's go ahead and make that its own room. So I'm going to place a register here. Now you see that bright pink color? That just means I've got rooms that overlap. And to make that pink go away, you just got to make them not overlap. And then once they don't overlap, you'll see how they collide like that. That makes it easy to place them. Okay, now we've got the stairwell here. We're probably not going to put a register in this stairwell. Also you'll notice this is a closet right here that comes off a bedroom too. Let's go ahead and put that closet. And let's group it here. Okay, now you got the stairwell here, and I'm going to group it with this landing up here. Okay. Okay. All right, so we got all the rooms put in for the second floor. That looks pretty good. Now we got to do the windows. Okay, our second floor is all built. Windows, walls, doors, floors, everything. Let's go ahead and turn the first floor back on. And let's turn the second floor floor plan off. And let's turn the first floor floor plan off so we can see our house. So there it is. Now the software, like I mentioned, is doing all of our area takeoffs for us. Okay, so now it's time to do the load calculations, but before we can do that, we need to tell it how many systems there's going to be. And this house is small enough for a single system, so we just need to place one single air handler. And we go into field draw, air handlers, and then alt click, and it placed a horizontal furnace in the attic of the house, which is what we're going to do. And that's good enough for now, but it's just basically there just simply to tell the software that there's only one system in this house. If we were doing two systems in this house, for example, we would place a second air handler, and then we would go into the data tables, and under systems there's two here now, and we'd go into the rooms and we would assign the rooms, each one of the rooms, to one or the other of those air handlers. Okay, but we only have one, so we don't need to worry about that. So we go back to HVAC draw and delete it. Okay, so we've got one there. Alright, so if you'll recall, I named all the rooms, but I also need to assign room types. The only two types that really matter are kitchens and bedrooms, and then everything else is other. So this is the living room, so that's an other. Dining kitchen, that's got a kitchen in it, so put that a kitchen. Master bedroom is a bedroom. Bed 3 is a bedroom. Bed 2 is a bedroom. Okay, so we've got a kitchen, 3 bedrooms, and everything else is other. That's fine. Now it's a 3-bedroom house, so the general rule of thumb, there's the rule of thumb again. The general rule of thumb is the number of occupants is the number of bedrooms plus 1. So there's 3 bedrooms, so there's 4. My general rule of thumb for where to put them is where are they likely to be during the hottest part of the day. They're not going to be in their bedrooms typically. They're probably going to be, let's put a couple in the living room, and let's put a couple in the dining room and kitchen. Okay, in the hottest time of the day, which is probably 5-6 o'clock in the evening. Okay, if you look at the rest of this room table, you'll see a bunch of stuff over here that's not filled out yet. So for each room, we have a heating load, a heating fraction, and a heating CFM. That should sound familiar from the earlier discussion. Cooling load, cooling fraction, cooling CFM, and then the duct size CFM. So this cooling load is going to come from the room by room load calcs. Okay, and then this cooling fraction is going to be the load of each room divided by the total, and a percent is going to go up here. And when we select the equipment for cooling CFM, we're going to have a cooling CFM. That's going to go there. So that's all that stuff we did in the table before, earlier in our discussion. It's going to fill that out for us. And it's also going to do the exact same thing for heating. So we've got a heating load, heating fraction, heating CFM. And then it's going to look at the heating CFM column. It's going to compare it to the cooling CFM column. It's going to pick the higher of those two numbers, and it's going to put it in this column here. And this is what it's going to use to size the ducts. It's this column here. So this total might be a little higher than our cooling CFM because it's going to take the higher of the two for each individual room. Now we can go and click on the Energy Gauge Loads button. The first thing it'll do is ask us to confirm that we want to save it. So we say yes, we want to save it. We'll give it a new name. National Home Performance Conference 2020. How about that? Save. Alright, now this is Energy Gauge. And it looks a little different. It is a different software program. They do come together. They do run together seamlessly, but they do go back and forth between the two. So we created the house in Quick Model. It did all the area takeoffs and knows all the wall types and all that kind of stuff. And now it's transferred that information over to Energy Gauge. But Energy Gauge needs to know a little bit more information. The first thing we have to tell it is the climate location. So let's just say that we're in California, Sacramento, and then it has built into it all the information you need for that city. Okay, and I'm going to use the manual J8 sizing design. Now I go back here. Now it needs to know about the cooling system. So I click Edit Cooling System. There are no cooling systems. Please add one by clicking the plus button. So I click that, and I'm just going to put in a basic central split, and I have to tell it which block. There's only one block, and that's all it really needs to know at this point. Now I can either go back or I can go straight to the heating system. Add a heating system. Let's call it a natural gas furnace, and serving block 1. You can put more information. The rest of this is not really necessary at this point. Now let's go straight to the duct system. The ducts are all in the attic. The air handler is in the attic. It's got R6. You can change all this information if you want to. We'll put in a default leakage. And this duct system, you have to tell it which heating and cooling system this duct system is assigned to. We only have one of each, so that's easy. And that's basically it. Now we go back to the main thing. The last thing to do is mechanical ventilation. What they typically do out here in California is a fan system. That's an exhaust fan running about 50 CFM or so. It's the ASHRAE 62.2, but it's running 100% of the time, and I don't know, 50 watts or so. Okay, and it's serving the only block there, and that's good enough for now. All right. So in California, our winter indoor is 68. And our summer indoor is 75. I'm going to use default infiltration. There's other ways to do that. I'm going to keep this simple for now. And that's pretty much all we need. And I'm going to click Calculate ACA Manual J Loads. And here's what we get. So on our heating load, we come out, it breaks it down by different components: windows, walls, ceilings, etc. Plus duct losses gives us a total of 29,694 BTUs per hour heating load. So we need to pick a furnace that provides just a little more than that much. But remember, the furnace is also the air handler for air conditioning, so we need to consider that as well. On the cooling side, it's a bit more complicated. It still breaks it down. Notice that the highest single load for cooling is well, in this case it's ducts. I think these are pretty leaky ducts, but also windows is way up there. Our total sensible load is 18,914 BTUs. In California, we're a hot, dry climate, so we don't have to worry too much about latent. So if we size our air conditioner to the sensible load, we should be fine. And that looks like it's going to be about a 2.5 ton air conditioner. It depends on a lot of different things. Don't have time to go through the whole look at the manufacturer's equipment tables and things like that, but take my word for it, this is going to be about a 2.5 ton system. You'll need to take a much more extensive class to learn how to do that, I'm afraid. But the point is that you look at the sensible load, you look at the manufacturer's equipment, and you pick an air conditioner that gives you just a little bit above that, and then you're going to look to see how much air that particular furnace puts out and what airflow is needed to meet this sensible load. Then you're going to check the latent load to make sure it can be met too. And like I said, in California, that's usually not a problem because the latent load is quite a bit smaller than the sensible load compared to other locations. So we're looking pretty good there. I think a 2.5 ton will be just fine. Next we go to the manual S portion. It has some summary information up here. There's only one block in this house. If there were more, there would be more choices over here. You can do up to 5 in a single system or a single house. We'll click on edit block. There's some information up here. It's just some summary of the stuff that we looked at before. It's just here for reference so we can refer to it very quickly. Manual S has some sizing criteria. For example, on your cooling side, the lowest they suggest that you go is 90% of your load. That's actually sizing for a little bit smaller. Highest they suggest you go is 115% of your load. And unless you have a 2-speed or variable speed, then there's some more allowances to oversize air conditioner for those. Generally, it's anywhere between 90% of your load and 115% of your load for cooling. For heating, you want at least 100%. You do not want to undersize on heating. That's a building code issue. But they suggest that you don't go over 140%. Okay? Unless, for some reason, you have to size up for more airflow to meet your cooling load. So there's a little checkbox here to accept, just to remind you that it's your responsibility to check all these, the designer's responsibility. And then there's these steps. Okay, the first step is if you know your AHRI information about the equipment that you want to install, you can go ahead and put it here. But generally the first pass through you don't. And so I just put 7 zeros. And then I just carry those over to the other side, and that just holds a place for now. Same thing on the heating and cooling capacities. You don't need to put anything in there just yet. Fan specification. So it's a 2.5 ton system. I'm just going to assume it's a standard fan motor. On the cooling side, I'm going to do the 400 CFM per tons as a starting point. That's going to be on high speed. Let's do heating on medium. On cooling, we'll do 1200 CFM, and I just know this, sorry, 1000 CFM, not 1200, 400 CFM per ton. It's 2.5 tons, and about 800. I just know this from experience. This is just a first pass through. This is a fairly iterative process. I'm going to start with just some default assumptions, 400 CFM per ton, so many BTUs per ton, sensible, and then I'm going to go through once, and then I'm going to come back and I'm going to check it. And then what I would normally do is then start looking at more specific actual pieces of equipment and start plugging those numbers in and fine-tuning things as I go. Okay. And then here what you typically want to design to is either 0.5 or 0.6. I usually design to 0.6. This was that pressure I was talking about earlier where the air handler is going to give you a certain number of CFMs as it's working against a certain pressure. There's a table that the furnace manufacturers provide, the airflow table, that shows a given furnace at a certain pressure resistance will provide a certain amount of CFM. And 400 CFM per tons is generally around between 0.5 and 0.6 inches of static pressure. And so that's what I'm going to start with. And again, I'm going to have to come back and I'm going to have to fine tune everything once I pick my actual equipment. And it may end up causing me to change things. Usually it doesn't, but sometimes it does. Okay, but this is just a first pass through. Okay, now it's going to ask me for my indoor conditions. It'll show some suggestions based on just some basic criteria, and those are usually fine. You can fine tune it if you want to. Now it's saying the design capacity. So I'm just going to put some numbers in here for now, and I'm going to pick a heating system that's slightly above my heating load of about 30. So I'm just going to say this is going to be 30. And these are kBTUs, so it's not 30,000, it's just 30. Don't need this for now. And then we've got a total capacity and sensible capacity. So my sensible capacity is going to be below 24 but above 18. So let's say 22 just for now. And we'll do the total at 24 just for now. Now I can save my work and go back to Quick Model. Okay, now you'll see that this table is now all filled out. So this was our room table. So here's all our rooms in the house, and we want to see which room is which. We can click on them. Here's our heating loads, our heating fractions, our heating CFM, our cooling loads, cooling fraction, and cooling CFM. And remember I said our cooling fractions have to add up to 1. There you go. Our cooling CFMs have to add up to what our total was, which in our other example and this example were 1,000. So there you go, it's 1,000. And I also said that our duct size CFM might be a little higher than our cooling CFM, which it is, 1,081 versus 1,000, because it's looking in each of these two columns, the heating CFM and cooling CFM, and it's picking the higher of the two. And in a couple cases right here, what room is that? The master bath, the heating CFM was slightly higher than the cooling CFM. So that's the number it's going to use. Same thing with the living room. Okay, so these are the CFMs that it's going to use to size the ducts. Okay, so let's review. So we did step 1 of the design process we talked about earlier, which was collect all the information about the house, and that was using the floor plans to calculate the areas. And we made some assumptions for the types of walls and the types of windows. Then step 2 was to do the load calculations, which was through energy gauge, and we did all that without too much trouble. And then step 3 was size the equipment, and once you size the equipment, you know the airflow. And that's basically where we are right now. So we have our airflow that we're going to design to. We know how much needs to go to each room. Now we need to size the ducts. Step 4 is to design the distribution system or the duct system. I picked a fairly challenging house. This is a 2-story house. It's a lot more challenging than a single-story house where all your registers in the ceiling and all your ducts are in the attic. The problem with a 2-story house is your furnace is in the attic, but you got to get ducts down to the first floor, and they have to pass through the second floor. So I'm going to do this for you, and the way I typically do it is I put the registers in first. So let's place all the registers on the second floor at least. So we've got our air handler down. So this is a horizontal furnace in the attic, and you can change the dimensions of all these sections, but we have a furnace, we have an evaporator coil, we have a supply plenum, and we have a return plenum. Okay, and to place the registers, I'm just going to alt click, and you can see there's a little register there. It's a top entry register. You can change that to a side entry register, and you can rotate it by hitting tab. Okay, but these are ceiling registers with pretty decent clearance, we will assume, and so these will all be straight entry registers like that. Okay, you'll also notice that it throws a shadow on the floor of the room that we're looking at. Let me turn the floor plan back on for the second floor, and you'll see that that's the master bedroom. Okay, and if I look straight down from the top, here's the register here, and you can see the shadow on the floor. So I'm going to go with the school of thought of bringing the register back into the room and using a 1 or 3-way register and throw the air across towards the load. I'll probably need to move, let's see, I need to look and see where I'm going to have the attic access and the return grills and all that kind of stuff. The attic access will probably go over here. The return grill will probably go at the top of the stairs, and a lot of that kind of stuff you need to sort of figure out as you go. The nice thing is you can always kind of move things around. Okay, so top view. Got a register there. Let's put a register in this room. Oops, place an air handler. Go back to registers. Let's put a register in this room. On this one, I'm going to put it out over the window because I'm going to have a lot of stuff going on right here next to the air handler. So this one I'm going to have to put out over the window mainly because of that. Let's put one in here. Put one in the master bath. Let's put it in the master bath. Remember I said I was going to put one in the toilet room. A little one in there. Go in there, master bath. One in this middle bathroom. Okay, so I got all the second floor registers in. Now the hard part is figuring out how I'm going to get ducts down to the first floor. Okay, and usually the easiest way to do that, the least painful way to do that, is to take out a corner of a closet somewhere and build a chase. A chase is just a boxed in area. So I see this has a pretty good sized closet here in this bedroom. So I'm going to use this little corner right here, this corner of this closet, and put a chase there. And the way we draw chases in Quick Model is there's a chase feature here, and you just click it, and what it does is it puts a tube. Basically, that tube is a vertical duct. They're going to have to build a wall around it to hide it when they build the house, but this just shows you where the vertical duct is going to go down. So you'll recall I told the story about asking for a 12-inch clear chase to get the duct down. That's what I'm talking about. This duct is a 12-inch diameter duct. So what happened was when they built the house, they put a floor joist right through the middle of this chase that I had requested that they keep clear. So if I look at the first floor, I'm going to turn off the second floor, turn on the first floor, so you can remember the rooms. There's a living room here. I need to get a duct down there. There's a den. I need to get a register in there. There's an entry, a bath, a laundry, a kitchen, and a dining. This kitchen and dining are basically one big room. I'm hoping one register will handle both of those, but the living room is going to be a big room, so I got to get down there. So I'm going to assume that the floor joists are going to run front to back. So if I get down here, I can run a duct towards the front, and I can also run a duct towards the back. You have to know a little bit about structural. When you have stairs going down, there's usually beams around here, so it's probably going to be difficult to get past this beam unless this little ceiling down here gets dropped. So I'm afraid I'm just going to have to kind of plow ahead and show you what the assumptions I'm going to make, and then of course you're going to have to get these assumptions approved by the builder and the architect and the framer and everybody, but you got to take a first crack at it, and so that's what you're going to see is basically my taking a first crack at hoping the ducts are going to work the way I draw them. That's the hardest part of residential HVAC design, is not sizing the ducts or doing the load calcs. It's designing a system that will fit in the house the way they've designed it, because they very rarely will give you room for the ducts that you need. So you're going to have to ask for some things in order to make the project work. Okay, so I'm just going to dive right into it. So I've got one chase here going down through here. Let me turn the second floor back on. Here's a nice big walk-in closet back here. You can use some of these dead corners here. You notice how there's this kind of a little shelf right here, and these shelves stop, and there's some kind of a shoe shelf or something behind the door. I'm going to use this corner here, so I'm going to put a chase down in this corner so you can see it there. Okay, I also have to come to another room here. I'm going to go ahead and put another chase right here use up this corner of this closet. So this duct will come down and come back this way. This duct will go down and go back that way. Another thing I could do is you can put, sometimes behind these doors is a good place. So let's move this one. Let's move this one over here. Of course, it's going to depend on how the ceiling comes down too, as to whether we can hit the top of that chase. So I'm just kind of thinking out loud, and you're kind of hearing my thought process as I go through this. I do still need to get a big duct to get to the living room, which is directly below this master bedroom here. And I need to get a duct over here. Oh, look at there. I just noticed there's, let me move this air handler out of the way. Ah, they gave me a chase. I missed that. So that's good. It looks like they boxed out a place here for a chase, which was very kind of them. But that's the only chase they gave me. So we'll have to do the best we can. Alright, let's put a chase here. And so what I'll typically do is put down more chases than I need, and then use the ones that seem to make sense. Still having a little bit of challenge getting down to this living room in the back. Let me look at it from the back here. So this is looking at the back of the house. Turn off the second floor. So this downstairs room here, this living room, how am I going to get a duct into that room? That's going to be a bit of a challenge, because there's probably a beam running along the side of this stairwell here, because these stairs drop down, and so there needs to be support of that wall. So it looks like maybe the best thing we can do is to put another chase here to serve the back, and it may just have to be a register. If we put a register here, a supply register, and it's blowing this direction towards this room, remember, it's got to get back to a return, and I'm going to put the return at the top of the stairs. There's no way I'm going to get a downstairs return in this house. It looks very, very difficult to do that. And so I'm going to come down here, put a register. I'm going to hit the top of a register, put a supply register down here. It's going to blow into this room, and the nice thing is that it's going to circulate. I'm going to blow it away from the stairs, so it's going to circulate out into this space here and mix with this room, and then come around and get sucked back up and be pushed rather up into the second floor, up to the return. I'd like to get a better located room register for the kitchen on the first floor, but it looks like putting a ceiling register right here won't be too bad. I can put a two-way here, and it will blow the air in this direction, and then it will migrate across the room to the stairs. So all the air that's going to the first floor is going to have to make its way to the stairs. So it's all going to have to come through here and then go up the stairs. So keep that in mind too, is what path does the air have to take to get back. Now we've got a laundry room and a bathroom and an entry that we have to get registers in. One idea for these little bathrooms like this is it's generally okay to drop the ceiling, and you can actually do that in room mode. If you click on a room, you select a room like so, and down here it'll say drop ceiling by 1 foot. Okay, there we go. So you'll see what it did is it put a false ceiling in that room. So I have a 1 foot soffit in this bathroom. Now that's a little low. It's an 8 foot ceilings, and I've just dropped it a foot. So now that's a 7 foot ceiling in that bathroom. But we need that. We need that space, because we're going to come down in this chase right here. We're going to run through the floor joist, and once we drop through the floor joist and get into this little drop ceiling, then our duct can split up. We can put a high sidewall hitting the entry, we can put a little ceiling register in this powder room, and then we can put a high sidewall blowing into the laundry room over here. Okay, so that's just kind of my thought process right now. We'll have to check and see whether that's going to work, but I just want to get all my chases in as best as I can. So once I got the chases in, now let's put some, actually I missed one. Let's do this one. So this one is going to go down and hit the den in the front, and then I'm going to put another one back here that's going to go down and hit straight into the top of a register that's going to serve the living room. So back to HVAC draw, chase, just tuck it back in that corner there. Okay. Hopefully that works. Now you're going to need structural plans to make sure you're not, being chopped off, cut off by any things. And whenever you put these chases in here, be sure to coordinate with the framer and the builder to make sure that they leave those open so that they don't put a floor joist or even a ceiling joist truss across the top of these and screw up your chase. So you want to make sure that that's marked as being clear, not only on your plans but on the architectural and framing plans as well, so you don't have to go through tell them a stupid story about pizza. Okay, so now that I got my chases in there, I'm going to go ahead and put my registers on the first floor. And to do that, I'm going to turn off editing of the second floor so I don't accidentally place it on a second floor wall. So I want a register right at the bottom of this chase. So this register, this duct is going to come straight down into the top of a register. Let me see if I can get it there. There we go. That looks pretty good. Let's scoot over. Okay. So we'll put a little flex duct extender on the end of that. Okay, it doesn't look like I lined it up. Let me look from the back here. Need to pull it over. I think it's right there. Okay, good. All right, so that's the living room. Similarly, the kitchen is going to be right there. Turn it sideways. So this one hits there. This one hits the kitchen also. So I have a choice between this one and this one. I don't think I'm going to need both of those registers. If I do, I can come back to it. But I actually kind of like this one better. So I'm going to go ahead and move this one over here. Look straight down from the top. Let's delete this chase. So we're going to use this chase here. For the laundry, bath, and entry, use this chase. And those registers, I'm going to have to go way down here to put these registers in. One's going to be a high sidewall. I got to get inside that little space to do that. Right there. Okay. So that's that dropped ceiling above the bathroom, and I'm putting a register in the wall blowing into this entry. I'm going to do something very similar on this other side. If I can loop around here, got to get inside. There we go. Okay. There we go. Okay. Now this one is in a very tight space, so we definitely want that one to be a side entry register like that, so the duct can come in and hit it from the side instead of having to loop over. We have very limited space. There's no way you'd fit a duct to come up and down into that duct, that register. So we'll hit it like that. These two we can hit this way, so that's going to be a very tight little space there. We're going to come down through this chase here, through the floor joist, get into this drop ceiling, and then there's going to have to be two splits. It's going to split into this one and this one and then this one. Okay. Alright, that's going to be fun. Let's see, I think the last register we need is down here in this room, the den, the bottom of this chase. Sidewall. There we go. And I want that one a little bit out into the room, so I'm going to make that one a side entry as well. So it's going to come straight off this duct, through the floor registers, hit that boot, or through the floor joist, excuse me, and hit that boot. Okay? Alright. So now we just got to draw the ducts. Oh, Sorry, one big thing we can't forget is the return grill. Let me turn the second floor plan back on, and we've got this area here, so we have to leave room. This is where it starts getting really tricky, and this is where it's nice having a 3D software like this and the ability to move stuff around. So if I click on air handlers, I can move the air handler around. Be sure to turn the edit back on. So I move the edit around. I don't want to cover the top of these chase. So what I need is a room for an attic access as well as room for a return grill. Let's do this. We'll put the attic access at the top of the stairs, and we'll put the return grill right over here. I think that'll work a little better. You can always move this around. Chances are no one's going to like your first attempt, but you got to do the best you can. Return grill is just a register, but you can change the size of these all, by the way. I'm going to make it a 20 by 30. I'm going to get a nice big register. I suggest you put in the biggest return grill you can. There's nothing, you cannot put in too big of a return grill. And I'm going to have it right here. That'll leave room for the attic access to sit right here, and they can service the furnace by standing on the ladder. You don't need, I suppose I could scoot it over and have room to put a little catwalk there with an attic access getting up onto the furnace platform. Okay, so I think that'll work okay. Alright, now the fun stuff. Time to make spaghetti. Alright, so what I typically do is I will take a plenum like this, and I will either divide it into 4 or 6. And given that I've got 4 chases going down and a bunch of registers on top, I'm going to divide it into 6. So I'm going to put 6 start collars. Oops, I noticed my this one register is buried under the furnace. I'm going to pull it out. See where it sits in the bathroom there. Okay, so I'm going to put 6 start collars on this air handler. 1, 2, 3, and you can move those around however you want. The default size is 12, and you can change that if you want. I'm going to put this one up high. Actually, what I could do, because there's a register right here and I know that's going to get in the way, so let me delete that one. I'm going to put it on the top here. It's a little unusual. I usually stick to the sides. I try really hard to avoid putting start collars or any kind of takeoff on the end of the plenum, because the air is coming out and it smashes into the end of the plenum, and certain size duct here will actually deliver more air than the same size duct on the side because the air is hitting it straight through. So I try to avoid that and put it just on the sides. And what I have found is that as the air comes out of here and smashes into the end, the pressure's higher here and it gets lower as you drop back. So the runs that are the longest, the ones that go downstairs, I'm going to attach to the start collars on the ends. And then these are as I get farther this way, away from the end where the pressure is not as high, I'll start running off to some of the upstairs rooms like that. Okay, I'll show you what I mean when we get there. So I need 3 more start collars on this side. 1, 2, 3. Move those around. Just going to space them out. These are 12s. These probably won't be 12-inch trunks. Also, if I needed to, I could make this plenum longer. Right now it's 36. If I wanted to, I could make it a 48-inch long plenum and get a lot more room, but I don't think we need that. Let's just leave it at 36. Okay. Alright, so now I got to go from the start collars to these chases going down. And I try to keep things symmetrical. So I've got these 2 over here, so I'm going to come off of here and hit these 2, and then I'm going to come off of here and wrap around and hit those 2 back there, so that the air coming through for the longest runs going downstairs, the air is coming and splitting to the left and to the right. That's what I mean by symmetrical. That's just me. I've just found that works pretty well, and keeps the duct sizes fairly symmetrical and things like that. So, alright, here's the fun part. So, to draw a flex duct, you click on flex duct, You click here till it highlights, and then you click on one of these. And I'm going to pick the one that I think is going to be the larger of the two. And that's definitely going to be the one serving the kitchen and dining room below. So the larger of the two is going to be this one. So I'm going to hit that one first. So I click highlight that. I've highlighted the start color, I've highlighted the top of the chase, and then I hit the enter key and it draws a duct. There you go. So it connects the ducts like that. Pretty cool. Now this handle here, if I click on it and it says new fitting type, it's selected as a TY, and so if I click on that and hit enter, it turns it into a TY. And so now I go back to flex duct. I'm sorry, still at flex duct. Click there, enter, and now it drew a duct there. So there's a duct coming out here, goes straight through the TY, that's the larger of the two, goes down, and another duct splits and comes out and goes down there. And let's go downstairs and attach those. So this one's easy. And actually I think what I'll do is I'm going to shorten this chase by a foot. So it's an 8-foot long chase. I'm going to make it 7 just to give me a little bit of room. This would probably be a flex duct running down here anyways. So I just click there, hit enter, and that's pretty busy. If I click on a different tab, it cleans it up. Now these ducts are defaulting to 12 inches. I haven't sized them yet. Okay. Once they're sizes they're supposed to be, that'll be different. Okay. Now we need to turn off the second floor plan. We need to hit these 3 registers, 1, 2, 3, from the bottom of this chase. So go back to HVAC draw, hit flex duct, click here, and then I'm going to click what I think is going to be the bigger one, and it's probably going to be the entry. So hit that, bring this around, TY, hit enter, and then tab rotates the TYs around. Okay, flex duct, hit here. I'm going to say this one's the next biggest. Enter, there, enter to make a TY, and then from there to there, boom. Alright, now that's really busy. But again, these ducts aren't sized yet. And if I click on another mode, it turns off all those handles. So you can kind of see what's going to happen here. I think these are defaulting to 12-inch ducts, and we know that that's not how big the ducts are. We can actually change that by clicking it, and let's make it a 4-inch duct. 4-inch, just to clean it up a little bit. 4-inch, so we can kind of see what we're doing. Okay, there, that looks a lot better. And you can change your default sizes, by the way. Okay, I'm going to change that to 8, I think. Alright, so now we need to hit, so we hit these two, now we need to hit these 2 chases back here. So I'm just going to go from here to there, hit enter, pull it out, turn that into a TY, rotate it around, and then go from there to there. I'm going to pull this TY, click on fittings, select the TY, I'm going to pull it way over there. Now you notice how those ducts got all bunched up. That's not good installation practices, but I've actually seen ducts that look exactly like that. There's a command in here. You go to flex duct, select a duct, and then hit the R, and that restricts it back to the shortest length. Okay. And when you add a fitting, it adds another handle, so I can drag the middle of that around. And if I needed to add a handle over here for some reason to drag this around, what I do is I turn that handle into a splice, and then it creates another handle back behind it. So now that I can drag that splice around, or I can drag a handle around like so. Okay, that doesn't look too horrible so far. So that's all of the ducts serving the first floor. Now I'm probably going to come back and change this around, because I was able to serve the entire first floor off of 2 start collars, so I may not need 4 start collars to serve the upstairs. Let's try it, see if we can make it work with 2. Delete this one, move this one over. Okay, so I like to have the master suite on its own trunk. So we got a master suite here. I'm going to turn on the first floor plan so I kind of see it better, darken it up. Alright, so we got a register here, register there, register over there. So let's do this. I'm going to go from flex ducts from here to here. Okay, I'm going to pull this handle here, and I'm going to turn that into a splice and put a handle here, and that one I'm going to turn into a TY, and that one I'm going to connect to that register, turn that into a TY, tab it around, connect it there. Alright, just turn off these handles. So I've got a duct coming out here, goes to these 2 downstairs. I got a duct coming out here, it splits, goes to the master bedroom. The other split goes to the master bath, which then again splits into the master bath and the little toilet room. So that looks pretty good, actually. I can move these around as I need to. I just in HVAC draw start collars. If I grab a start collar, I can scooch it around wherever it needs to go. Alright, let's look at the other side here. So we've got register here in this bedroom, register here over this landing, and a register in this bedroom. So I'm going to say this one here will be the biggest. And then I'm going to pull this back, TY. Then the next biggest is probably going to be this one over here. Pull this back around. Remember that return grill is there. We got to watch out for that return grill. And then we'll hit this one like that. And then we've got this little dude tucked back in there. And alright, actually what I'm going to do now that I look at this is I'm going to change it around. Since I have to put another start collar here anyways to serve just that little bathroom, I'm going to split this up into 2. So I'm going to go ahead and delete this one, and let's see, I'm going to put these 2. So let's delete this fitting, and I'm going to go from here to here. So that's going to serve those 2 rooms. And then I'm going to add another start collar. Scoot these out a little bit. Put another start collar here, and that one is going to hit this bedroom. And this is kind of funky, and this is, you know, people complain about this. Oh, you ran your duct so long. It's not ideal, but remember that's an interior room. It hardly needs any air at all. We can go look at the table in a minute and look. So even if that's a 4-inch duct, that's probably more air than it actually needs because it's an interior room. There's the only load on this room is the ceiling above it. So it's got, you know, conditioned space on 5 sides of it and unconditioned space on 1 side. So I'm not too concerned about that. It looks funny. Doesn't look great, but it is what it is, and it should work fine. All right, so HVAC draw, flex duct, connect here, hit enter, stretch it out, kind of get things out of the way of each other. This is real life, people. This is 10 pounds of spaghetti in a 5-pound bag. Now what I could do, obviously this doesn't need to be that big of a duct either, so click on it. Let's do a 4-inch duct. There, that looks like a lot better. Okay. It's still kind of going through that other one there. I'm going to switch to top view here and scooch it over. Pull this out. Okay. All right. So I could also move that register back there into a little bit farther into the middle of the room. Can I get it out of the way? That looks better. All right, now we've got this return grill here, and we need to put a start collar on the return here. So there we go. Flex duct, start collar, grill, enter. Now this is going to be a big duct, so we'll make sure it has plenty of room to do its thing. And I'm also going to go ahead and tuck a return grill back into the corner of the master bedroom, because there's a lot of air going into this master bedroom. There's this huge room here, all of this room, and this room around here. So this is all the air for all of this room is going behind this door. And if we were to expect all that air to go out under that door, that's just too much, okay? So I'm going to go ahead and put another return grill, and I'm going to tuck it in this corner, and I can do the calculations later, but I'm going to make sure it's a nice big grill. I'm going to put a 24 by 24 in there so that it's quiet. It's inside the master bedroom, so you want it to be quiet. And I'm just going to come right off the top. Like that. Okay. Now what I'm going to have to do is I'm going to have to assign this return. I'm going to assign supplies to this return, because now I've got more than one return, and you have to tell the software what supplies are going to that return. Remember how we did that in our previous example earlier? Okay. Oops, I'm going wonky here. There we go. Okay. You'll notice that when you click on a handle, these arrows appear, and if you want to move it in one direction, just grab that arrow and it will only move that direction. If you can grab the arrow. There we go. Okay. Oops. Alright. I think we're doing pretty good. Let's get back on the front here. So we got that big return, we got that big return. This one's clearly going to be the bigger of the two because it's serving the rest of the house. This one is only serving the stuff in the bedroom. Alright, we need to finish the registers on the first floor. So let's go down, let's do this one. I want to get it right under there, so let's do top view, zoom down, registers, click on the register, scooch it around. Let's shorten this chase up just a smidge by a foot. Then do flex duct, click, click, flex duct, and that'll look better later. Flex duct, let's connect this to this, enter. I think we're good. Alright, so let's go back out to the front, turn this floor plan off. Take a look at our house. Let's get in a different mode, turn off the handles. There we go. Look at that. If you were to do a single line 2D drawing, you would never see some of those complexities that we're having to deal with, that the installers are going to have to deal with. Okay, next. RB2 does not have any supply branches assigned to it, so that's the second return. So it's reminding us that we need to go in to the duct table, and here's all our supply branches, SB1 through SB13, and it tells you what room they're located in, which is nice. Where's that little bathroom? Yeah, look at that, 8 CFM. I told you that's not going to need much air. 8 CFM. So even though that 4-inch duct is coming off doing a hard 180 and coming down, it only needs 4 CFM, which is essentially, or 8 CFM. It's essentially nothing. But it's going to get more than that, so we're good. We're good on that. I'm not worried at all about that one. Never was. What was I talking about? The other thing is the returns. Every supply is currently assigned to 1 return, but we have 2 returns, so we need to assign at least 1 supply to this return. Okay, this one down here, RB2, it has no airflow. The way to do that, it's very simple. So I know that that's in the master suite, and I know that this duct going to the master toilet, this duct going to the master bath, and this duct going to the master bedroom. So master bedroom, master bath, master toilet. Those 3 I need to assign to that other return, and I do that right here. RB1, change that, RB2. There we go. Now go to click out, click back. I don't get that message anymore. Okay, now here's all our ducts. We're in the duct table. So here's all our supply branches, our supply trunks, and if you want to see which ones those are, just click on it. So ST1 is that guy there. ST2, where are you? Must be hidden. Oh, it's down there. There's ST2 down in the floor. ST3 also down there. 4, 5, 6, 7, 8, 9, and 10. Okay. 2 return branches. Looks like we're good to go. Okay, before we can size the ducts, we need to calculate friction rates for all of these. We haven't done that yet. You'll notice that the friction rate that we have so far are really out of range. Okay, we haven't even talked about friction rate yet. So now let's go and look at friction rate. So there's a friction rate tab. Click on that. And this is basically the friction rate worksheet from Manual D. And if you'll recall, when we were in the Manual S portion, we specified our static pressure of the air handler for cooling to be 0.6. That number shows up right here. And we also said that that air handler at a static pressure of 0.6 will move 1,000 CFM. There's that number right there. Alright, now what we have to do is say, of that 0.6, what is eaten up by various pieces of equipment along the way? Things that the air passes through that causes a static pressure drop. The biggest one by far is usually the indoor coil, or the evaporator coil, or the direct expansion coil, whatever you call it. It goes by a variety of names, but it's this guy here. And usually out of the 0.6, that usually, if you go to look, you would have to look at the actual coil itself, and the manufacturer will give you a table that says at this many CFM this coil has this much static pressure drop. Okay, and you want something that's around the 0.25 range. Lower is better. You can always upsize your coil. If if you have a 2.5 ton system, you can put a 3.5 or maybe even a 4-ton coil on that thing, as long as there's an AHRI rating for that combination. And what that does is it gives it a much bigger coil area that lets air pass through better. It has better heat exchange, and what you'll find in the tables is that it actually improves the efficiency, the SEER and the EER rating. But the main thing it does is it has much less of a static pressure drop through it. So you want something around 0.25. Then there's a whole bunch of accessories in here. We don't have many of these. Heat exchanger, no. Low efficiency filter, no. We're going to put a high efficiency filter, and you want to design those like the MERV 13s to about 0.1. That's pretty dramatic. Electronic filters and then supply outlets are usually 0.03, and return grills are 0.03. Is very common. This is a manual T issue. You would go to the specs for the supply registers and look in there and say, all right, at a static pressure of about 0.03, what's the throw, what's the noise, what's the etc. at the CFM that I'm talking about. So that's a manual T issue. We don't have any of these other things. We might put a damper on there. Those are around 0.03, 0.05, sometimes a little more. It depends. Okay, but that's pretty reasonable. This is about where you want to be in this range here. Now, it takes this number, the 0.41, and plugs it into this equation up here, and it calculates the available static pressure. So what did you start with? 0.6. What is your component pressure losses? 0.41. 0.6 minus 0.41 is 0.19. Okay. Then step 4 is to calculate your total equivalent lengths. That's a different table. All right. So that table's up here. TEL. We'll click on that, and then it brings us here. So for each branch, going to each room, what it does is based on how we draw it, and it does this better for flex duct than it does for sheet metal or rigid ducts, just by the nature of fittings and how they work and stuff like that. So there's a certain amount of, it'll do it automatically for you, but you also have to come in and do some stuff on your own. And so I'll show you that. There's this you can edit any of these numbers. Okay, these come from Manual D. They're different fittings in Manual D, and these are the equivalent lengths. So for this first run here, supply 1 is this guy going way down there, I think. Let's see. Yep. Has 16 feet of duct, 10 total equivalent lengths for the register boot, 35 for the start collar, 5 for a TY, and then you can throw some more in there for other miscellaneous items, such as 90-degree bends. And so that's a Manual D thing. You'll have to take a class on Manual D to learn how to do that in more detail. But I usually come in here and I'll add, at least 15 to 20 for every 90-degree bend, okay, that I see. And then you have to just kind of fine-tune your total equivalent lengths. Now the total equivalent lengths are fed back into this calculation here. So you got your supply side and your return side. So this, whatever run we're looking at up here, you can pick whatever one you want to see in this field or this screen. It shows it here, and then it takes that number, and this is your final step, step 5, friction rate design value. The equation for friction rate is your available static pressure, this number here, times 100 divided by your total equivalent lengths, this number here. So 0.19 times 100 divided by 140. And that's a little high, so I probably need to shave that down a little bit, probably put some more total equivalent lengths in there. I'll come back here and I'll plug in, I probably see some 90s in here, so let me put like 30 more feet in that one. I'll put 30 in this one. I'm just kind of guessing right now, but you'd have to go through and do this more precisely. And then you come up here and look at your friction rates, and they're normally going to be around 0.1. So here's 0.11, 0.09, 0.08, 0.07, 0.08, 0.11. Okay. So they're right around 0.1. This one, bed 3, is a little high, but that's a short run. Okay, that's possible. That might be the actual friction rate. But if you look at these fittings, make sure those are right. You come in, add any additional total equivalent lengths based on what you see. So there's a little bit of automatic stuff, a little bit of manual stuff you have to do, and get your friction rates in there. And this is starting to look pretty good. Okay, so once we got our friction rates in there, we can go back to our duct table. Okay, now we hit the magic auto size ducts, and here's all our new duct sizes. 9, 4 in the entry, that's interesting. 5, 4, 6, 6, 5, 7, 4, 6, 4, 7, 6. Here's our friction rates. Here's our trunks. Here's our returns. What kind of velocities do we have here? 790 and 535. Friction rates are pretty low. Total airflows. Okay. Those are looking okay. Some of these higher friction rates, 0.14, 0.12, those seem a little low. I just ballparked them. I could go back and tweak those a little bit. Got my 2 return branches. Everything's vinyl flex. You can change that duct type here. But I'm thinking this is a pretty good first crack at it. You know, you're gonna then kind of go back, check all your work. Then you're gonna maybe talk to the builder, talk to the HVAC subcontractor, find out what brand of equipment they want to use, look up some actual pieces of equipment, plug those numbers in, fine tune it, come back. You always want to go back and recalculate your loads at the very end. You always want to come back and resize your ducts at the very end. Let's go back and take a look at this. Let's see. In HVAC draw, you can check a box to show the duct sizes. As far as printing something out to give to someone, probably there's several ways to do this. What people are used to is 2D view straight from the top, so you can certainly do that. Top 2D view, maybe turn off the rooms and turn on the floor plans, and then darken the floor plans. So this is a second floor plan. You can barely see the duct sizes in there. See our chases, ceiling registers. Okay, master bedroom. Stuff is hidden, and stuff will be hidden. There's no way to do this perfectly. You could come in and, let's say, go to HVAC draw and move stuff around like so. Let's try this. Kind of get it out of the way. But this one's still in the way. Let's move this one. There we go. Now we can see this register there. Cool. Okay. Alright, so there's one option. Just as a starting point, you could also print out the duct table to show lengths in feet and diameter, so they could add up all the 9 inches and figure out how long they need to be. I forgot to mention we do have velocity here. You can also size each of the supply registers. They default to 12 by 6, but you probably want to come through, if you wanted to get that precise, you could size each register. Here's our return grills down here. So this duct table is almost a parts list. You can also go to the friction rate table, total equivalent lengths. The other thing, as far as drawings to give someone, if you were to hand this to an installer and ask them to install it, I think one of the best things you can do is just a bunch of isometric drawings like this. Show the rooms and just take a screenshot from this direction, take a screenshot from this direction, take a screenshot from the back, take a screenshot from the left, and then zoom in on some of this other craziness and show something like this. I can turn off these duct sizes too, if that helps. Okay. All right. Well, there you go. I hope you enjoyed that. I hope you learned something. Thank you for spending time and spending time inside my head with me. Thank you for letting me think out loud. I hope you all will stay safe, stay healthy, and get out there and do good work. Thanks very much.